This is pre-calculus final exam review 1B, problem 11. Solve for x. The equation is 2 sine squared of x plus 5x equals negative 3. Find all solutions on the interval between 0 and 2 pi. Okay, so we're given an interval. We're not going to have infinitely many to find. This can be solved by factoring. So first of all, I want to set the equation equal to 0 so I can use the zero product property. I'm going to add 3 so I can solve. Equals 0. Okay. Now what I want to do is I just want to consider, let's just substitute a variable for the sine of x. Okay, let's say that that's a. Okay, so sine of x equals a. All right, so what I've got here in that case is 2 times a squared plus 5 times a plus 3 equals 0. So how would you factor that? I'm going to look for factors of, this is hard AC, I'm going to look for factors of 6, whose sum is 5, and those are 2 and 3. First times first is 2a to the second, so that has to be 2a times a. Outer times outer has to be a magic number, so I'm going to say that outer times outer is 2. So 2a times 1, this is the other a, gives me 2a. And inner times inner has to be 3, so one of the inners is a, and then the other inner should be 3 to give me 3a. And then last times last is 3. Alright, now what I'm going to do is I'm going to substitute sine of x back in where a is. Okay, so I have 2 sine of x plus 3 times sine of x plus 1 equals 0. I'm going to set both of these factors equal to 0 and solve both equations. Okay, so here I'm going to subtract 3. Oops. Two sine of x equals negative 3, and then divide by 2. So the sine of x equals negative 3 over 2. Here I'm just going to subtract 1. Okay, now you know that the range of sine is only between negative 1 and positive 1. So you could never have negative 1 1/2, right? That's an impossibility. Sine can never equal negative 1 1/2, so I don't have to take that any further. But sine can equal negative 1. The sine of negative 1, according to my trig card, the angle that will give me sine equals negative 1 is 3 pi over 2. That's a quadrantal angle, and so that's the only one that solves this equation. So there's your answer.